Let's do something similar with triangles. Now, we'll find that we've run into similar things where if we define a type of triangle one way, we end up getting consequences. So which of these have all three sides the same length? It turns out that A, E, and J do. And once again, we often notate that with a single dash through them. Now, if we force all three angles to be the same size, that also makes an equilateral triangle. This is why we don't define a type of triangle having three angles the same size. If we wanted to, we would call that equiangular, but we don't talk about equiangular triangles because if I have equilateral triangles, I get all three angles the same. Now, isosceles triangles, there are a lot of them in there. Some people would argue that they wouldn't want to include A in here because it's equilateral, but it has at least two sides the same length, so we're going to say it's isosceles. Once again, some people will say exactly two. Think back to trapezoids where it's exactly one set of parallel lines versus at least one. We're going to go with at least two sides the same length, making something isosceles. So if we do that, we have A, B, E, G, H, I, J, L, and M are all isosceles. Now, at least two angles the same size ends up being the same. Once again, we don't talk about something that has two sides the same or two angles the same because that's just a consequence of something being isosceles. So these are ways we categorize triangles by their sides. It just turns out we can also use that to categorize them by how many angles they have the same. Now, if we just compare their measures to a right angle, we end up with three categories of triangles. If all angles are smaller than a right angle, if it's an acute triangle, well, that's A, B, E, J, L, and N. If it has a right angle, well, that's C, G, H, and K. Notice none of those right triangles are equilateral triangles. A couple of them are isosceles. G and H are isosceles right triangles. But there are no equilateral triangles that are right. Now, if we have an obtuse triangle, that's D, F, I, and M. So I, we can see it's obtuse. It has an angle greater than 90. Now, could we have a triangle with two right angles? Well, let's think about it. Here's me trying to build a triangle with two right angles. These can't touch, so we can't make a triangle. Two obtuse angles is even worse. So we'll always only have one right angle or one obtuse angle. Now let's talk about how those triangle relationships break things down into different types of triangles. Now, if we classify by sides, every triangle falls into one of three categories. It's either equilateral, isosceles, this is my weakness, spelling isosceles, or scalene. As you may remember, equilateral is 3 sides the same. Isosceles is at least 2 sides the same. And scalene is no sides the same. Now, you may remember that we found that all equilateral triangles are isosceles triangles. So you can imagine there's kind of a bigger box where the isosceles triangles contain the equilateral triangles. Well, now let's think about the other types of triangles. If we classify by angle, we first have acute triangles. Now, how do these triangles fit inside these? Well, we know all equilateral triangles will be acute triangles. So if I'm drawing my purple acute box, it's going to contain all the equilaterals. But I can have an isosceles triangle that is right or obtuse. So it's not going to have all of the isosceles triangles or all of the scalene triangles. Similarly, my right triangles can be either isosceles or scalene. They can't be equilateral, but they can be isosceles or scalene. And similarly, obtuse triangles can be either isosceles or scalene. We'll sometimes name a triangle by saying which categories it fits into. If it's equilateral, we just call it equilateral, but we can have acute isosceles, acute right, acute obtuse, scalene right, scalene obtuse. I'll draw some examples. Here's a classic scalene right triangle. I'll try to draw an isosceles right triangle. We'll pretend that those are the same length. Here's an isosceles acute, a scalene acute, whereas we can have a scalene obtuse triangle and an isosceles obtuse triangle. And so we have triangles that fit into each of those categories.